Thank you for visiting this channel. Today we are diving into something super exciting which we worked on, which is about the CNN model to recognize the handwritten digits. Now, we will be using it in not just one data set but two data sets. The first one being MNIST data set, which is a basic standard handwritten digit, and the other one which is EMNIST data set, which includes even more varieties which can be complex with both letters and digits. So our goal is to create a model that can accurately classify these digits and letters, whether it's from simple shapes in MNIST or the more complex characters in EMNIST. So this is a fantastic way to see the power of CNN in action as they learn to recognize and interpret all kinds of unique handwriting styles. Now, if you're curious about the code or you want to try the model out, then the link is right down in the description. Please check it out.
We have
Now,
chosen CNN for digit classification. To start with, why we have chosen CNN over other machine learning algorithms. The main reason is that CNN are designed to analyze image data like our handwritten digits from the EMNST dataset. And the CNNs have a special ability to detect and learn visually patterns like edges, shapes, and even complex structures through a layered structure of convolution filters. And in simpler words, it's like CNN automatically recognize features starting with the basic ones like lines and curves and gradually moving to more complex structures like whole digits. And this is what we mean by CNN capacity to learn spatial hierarchies. And they can capture the relationship between pixels that from a coherent image such as digits. And now how the CNN works means basically it have a convolution layers. Like in our model, we start with convolution layer where small filters also known as kernels slide over the image. And next, each filter will detect specific features like edges or textures by focusing on a small region of the image. To think of each convolution layer filter as a feature detector, helping the network understand different patterns within the image one layer at a time. And our model's first convolution layer learn the basic shapes like horizontal or vertical lines, which deeper layers learn complex patterns that make up entire digits. And we have a ReLU, which is an activation function. After convolution, we apply an activation function. ReLU are like they are rectified linear units. It helps the model to capture only important patterns by removing the negative values, which reduce the computation and allow for faster learning. And using ReLU ensures that our CNN is more efficient and focus only on the necessary features. And next we have pooling layers. And following the convolution and activation stages, we have pooling layers, specifically maximum pooling. And the max pooling reduces the size of each feature map by keeping only the maximum value in a small region of the image. And this step is essential because it makes the model more manageable by reducing the amount of data while retaining key features. This pooling also adds invariance to the model. It's less sensitive to small changes like slight rotations or shift in the digits. And next, it will flatten. After we have extracted our features with the convolution and pooling layers, the CNN flattens all the future maps into a single long vector. Like this step prepares of future for the next stage of processing, like which is done by fully connected layers. And the fully connected layers are similar to a layers in which the traditional neural networks, where every neuron connects to each neuron in the next layer. And in this part, the CNN learns to combine the features it extracted earlier to predict what digit each image represents. And our model has a few fully connected layers to improve accuracy and generalization. And finally, we reach the output layer, which contains 10 neurons, one for each possible digit from 0 to 9. And each neuron in this layer outputs a probability score, like showing how likely it is that the input image represents a particular digit. And the digit with the highest probability is selected the model's prediction. And the main advantages of CNN for image data is that it will automatically identify and learn the features, like starting from edges to the complex shapes, and also work with the images of varying sizes and details will done with the pooling layers. And also, they are capable of learning spatial hierarchies, making them highly effective for image based tasks. So, our CNN model learns from thousands of EMNIST images, capturing complex variations in digit handwriting, and it can generalize well to new images, accurately classifying digits even if they are vary slightly. So, CNN are the best tool for the many image recognition systems due to their ability to automatically capture meaningful patterns. For our MNIST and EMNIST data classification, CNN's layered architecture, including convolution, pooling, and fully connected layers, enables the model to transform raw images into accurate predictions.
Now that we have talked about the reason of why we chose CNN, let's dive into the structure of our convolutional neural network. So, this model, as you all know, is designed to classify images like handwritten digits. Let's break down each part of this network step by step. So, we start with an input, which is a grayscale image of size 28 by 28. This single channel is what the model will try to classify. Next up, we have our first convolution block. This block includes two convolutional layers and a max pooling layer. First, we apply a convolutional layer with 32 filters, each of size 3 by 3. This layer scans the image to detect features like edges and textures. After each convolution, we add a ReLU activation function to introduce a non-linearity, allowing the model to learn more complex features. We then add another 3 by 3 convolution with 32 filters and apply ReLU again and to enhance the feature extraction. Finally, we downsample the image with a 2 by 2 max pooling layer. Max pooling basically reduces the spiral size, making computations faster while keeping the important information with us. The second convolutional block is similar with more filters though. We start with 64 filter convolution, again with a 3 by 3 kernel, allowing followed by the ReLU. Then another 3 by 3 convolution with 64 filters and another ReLU. We end it with 2 by 2 max pooling layer to reduce the dimensions. So by now the network has learned more detailed and complex patterns in the image. After the two convolutional blocks, we flatten our feature maps. So flattening converts the 2D feature maps into 1D vector so it can be fed into a fully connected layers. Now we enter the fully connected layer or the dense layer. So here we have 256 units followed by a ReLU activation. We add a dropout layer with a 50% dropout rate to prevent overfitting. So it randomly drops neurons during the training to improve generalization. Then we add another fully connected layer with 128 units followed by ReLU and another dropout layer. This continues refining our features as we move closer to making a prediction. Finally, we have an output layer. So this layer has 10 units, one for each digit from 0 to 9, and this layer outputs a probability distribution over these classes, and the highest value indicates the predicted digit. And that's the full structure of our CNN model. Uh, Now we will be heading towards the code part of it. So I'll let Pramod and Dinesh handle that.
Hello everyone, a very warm welcome. Today I am here to share my experiences while I am doing a project named Handwritten Digit Classification and Recognition. Today I am here to take you through an exciting journey where machine learning meets human creativity. Imagine a machine is recognizing your handwritten notes and grade them accurately. So while when the machine is recognizing and how the machine is recognizing, then we are going to achieve with the concept called handwritten digit classification and recognition. Recognition will be used when we are writing or at a real time. It is going to recognize and classify the digits we are writing through camera or when we are writing with touch screen also. Hand digit recognition is an essential part of optical character recognition technology. This project leverages machine learning algorithms to identify and classify the human written digit classification classify the human digit written numbers from 0 to 9. Now I'm going to share how the handwritten digit classification can be achieved and what kind of code we are going to write and what kind of machine learning algorithms we are going to use to achieve the output and the targeted values. So at first, the handwritten digit classification project or recognition or classification can be done with several nearly 7 to 8 number of algorithms from starting random forest, KNN algorithm, CNN, SVM we can achieve through SVM when we are going to increase the accuracy percentage with grid search algorithm too. After that, we can achieve it with linear regressions and classifications. Let me share how we are going to achieve what kind of code we are going to write for a hand digit recognition. So basically, I had taken every single algorithm and classified and how trained the data. I had done this project with MNIST dataset is publicly available. So as we discussed, we are going to do and classify with 7 different algorithms. Let's start with handwritten forest, and I'm going to explain. So basically, when I was doing with 7 different algorithms to classify handwritten digits, so I got a different kind of accuracy within every single algorithm. Let me I'm going to share about every single algorithm. At last, when I have completed this whole project, I got to know that CNN algorithm is the best algorithm. So here, when I'm doing the handwritten digit recognition and classification with random forest, I was experienced with an test accuracy of 0.9686 and the validation accuracy was 0.96 and 925. So with random forest we are achieving nearly 0.96% of accuracy. After that, when we are going to use SVM algorithm, we can see here the when we are importing the required libraries and and the digits and when we are plotting it into a matrix and we are going to log it and like taking dependent and independent variables classifying them, so we are going to check. And here we can see a confusion matrix where the diagonal elements are the accurate recognizing elements. So 311, 3188 or 3677, these kind of diagonal elements are best accuracy percentages where we can classify for every single digit. So here we are doing the precision recall and F1 score while checking for the accuracy score. So here you can see that 0.97, 0.98 of the recall and F1 score of 0.96 of the every single digit present from 0 to 9. So while when we are etching these to increase the accuracy for the to increase accuracy for the SVM or using SVM model, we can go further advanced like using non-kernel and kernel models. So in that, in non-kernel model, while we are training it, we will get an accuracy of 0.8892. So in basic SVM algorithm, we are going to achieve 0.91 percentage of accuracy when we are using it with non-linear kernel. We are nearly getting 0.88 like 88% of the accuracy. So when we go further, when we are using grid search CV, we are going to attain nearly 94% of the accuracy. So here you can see the loss percentage graphs and the diagonal confusion matrix. So here we can achieve nearly 94% of the accuracy where in basic SVM we have achieved 0.91. So like that, As the same, when we are going to uh, uh, compare between the FNN and CNN means convolutional neural network. So here we can see that when we are classifying and comparing with FNN and CNN, we had used TensorFlow library. So it and with TensorFlow, we are importing the required MNIST datasets, and after that, we are going to uh, train the digits and check the digits whether how they are getting trained, and testing the label digits. So here, while training the dataset, we can see here nearly 20 epochs were done, which in for every single epoch, the model is going to check the whole data set, and it is going to train as a whole. As like that, here we had 20 epochs. So the model got trained for with 20 epoch nature. So and we are after checking the loss percentage and the accuracy percentage. Here the accuracy percentage of the comparing FNN and CNN. CNN is getting better accuracy. It is nearly 0.97 percentage of the accuracy. That means 97% of the accuracy was present, and we are getting it is occurred. So after that, we can check about hand digit classification. As I told that the total when I told about FNN, it is going nearly 0.97, and with CNN 0.99 of the like 99% of the accuracies attained by the model when using CNN. So comparing CNN and FNN, after that we are going to check about a KNN algorithm. It is a it is a classification algorithm. You can see that the test accuracy attained was 0.967, so that 96% of that accuracy was attained. Here random forest and knn are having same test accuracy. After that, after classifying, we can use gradio library to recognize that. So now I'm going to explain every single line of code of which we used for uh, handwritten digit classification using CNN algorithm. So let's start. Let's dive into the code. At first, while training with MNIST with using CNN algorithm, we have to use any Python libraries frameworks. So like PyTorch or TensorFlow. Here we had used PyTorch. So we are going to install the Torch library like with along with Matplotlib and Seaborn. So after installing that, we are importing the torch and torch nn dot nn. This torch nn will take the number of digit and more number of digit and more number of space is going to apply to the dataset we are going to import. So after loading the test and train dataset separately, so we are going to take the train dataset and we are going to drop a label column from the train dataset, because while we are going to train the remaining dataset, and we are going to test the dataset with the label columns, where in label nearly 0 to 9 digits were classified with different kind of writings. So that after dropping the label column, we are going to reshape the train values and test values as uh, changing the data type with as float 32. In default, it is going to be in int data type, I and integer data type. So we are going to change it into float 32 data type, which will give more size and accurate dimension as we change for float 32, and we are going to divide it with 255.0. Here why we are using 255.0 for dividing the values after changing into data types. So here the digits we are using will be nearly with black and white colors. So the any color having a range of 0 to 255 is the maximum range. So when we are going to divide it 255, it is going to change the dimension with as 0 comma 1. So we are going to get a better understanding how the classification is going on between the white black color changing. So we had used 255. So here you can see that black and white digits were classified, no other colors were used. So with dividing 255, so we can get a better dimension to get and better understanding how they are getting classified. So here we are going to so here we are going to plot how the digits were classified before completely training the data set. Here you can see that the perfect recognition of the 1 to 9, whether different kind of writing styles are present. So as we are going to plotting how many uh, in a data set of nearly 60,000, how many digits are classified into how many numbers? Like 0 is classified 4,000 times and 1 for more than nearly 5,000. Like these were classified in this type. These were classified in this type. So after that, we are going to take the class big data set. So data set. So here we are going to taking the images and labels and transforming it as a get item. We are going to create a functions a get item and idx. So we are going to transform in the tensorflow uh, code. So it is a python code which will be easier to classify the digits. So we are going to train the data set as xtrain and bytrain. So we have given these variables classified in the before discussed part or code. So here the train dataset and the train loader and the test dataset and test loader. These are classified like in train loader, the digits were stored as a batch size of 64 and test loader as the same batch size of 64, and the shuffle was allowed for train loader because different kind of data set data digits were has to be trained and recognized. So it may get and give better accuracy and better recognition while testing the data set. So here we have taken, as I explained, torch.nn and torch.nn functional, we are going to use for better size, more memory size. So as creating a CNN function and the input shape. So how CNN works? In CNN, the digit is have the digit matrix is classified as the input layer. So it is here the input layer and two or more hidden layers, and after that an output layer. It is also called as it is an output layer which is it is going to take the targeted or recognized digit. So here we are going to take input shape as 1 and hidden digits 128 and output shape as 10. So while the digit pixels were classified and entered into the from input to hidden units, it is going to classify more. So it is going to attain for every single pixel layer, and at last it is going to the pixels are going to attain as a single digit to recognize by the machine model. So at a flattened layer will be attained in the middle, so that passing through the flattened model or flattened layer, the whole pixels which were separated before were going to attach and getting, and it will show a digit classified handwritten digit, so that the machine can recognize it correctly. So here we have used the stride at kernel size and internals and outernals and the padding. These were used in hidden layers where padding will give an extra layer, as I had explained about the kernel size, internals, outernals, and the stride and the padding. Now here we can see that three convolutional blocks and three different blocks were present. They may be having the same kernel size and stride padding values. These blocks makes that it is going to train with better accuracy. Here there is a uh, data type. There is a function named sequential. Sequential initializes the working of the neural network effectively. So as we are moving forward, here we can see that the criterion having cross entropy loss. In this, here we had used activation layer named ReLU. So basically, what ReLU does, then in an image classification, sometimes in the matrix pixel matrix, we may have negative values like -1, -6, and different negative values. While with using that activation layer relu, or in activation layer there are different number of activation layers like relu, sigmoid, and many other. So we are using relu for better importance, and it is going to check the non-linearity. So with non-linearity the model can uh, train a better with better accuracy. So that we had used relu, it is going to make the negative pixel values into the make it as a 1. So here we cannot experience the negative values. If it is having 0 or positive values, it is going to make it 0, or having the same positive integers or numbers. But if we are having any negative integers, it is going to convert it into 1, so that we are not going to have error or decreasing the any kind of accuracy. So after that we are going to check about the and cross entropy loss on how much of loss we were experiencing. After that we are going to check about these things, CPU and device was, all these were for recognizing with while we are writing in with touch screen. And we have with recognition, recogni- with recognition we can use a screen, like using some ready-made GUIs named Gradios and many others, and with cameras using OpenCV library, installing it and using it. So here we're getting ready for the recognition part as with device CPU. Before that, when we are checking about the loss percentage of the function, how much loss while training for every single epoch. Here we had taken epochs near R5. So for every single epoch, how much loss percentage function was decreasing. So here you can see gradually from 0.3 to 0.05 for every single epoch the loss function is decreased, so that the better accuracy recognition is going to increase. So here we are going to check about the predictions in the images. After that, when we are going to present the test data on the, when we are going to check how the test model was trained, how it is going to predict the test data. Here you can see that with different kind of writings, 2 was predicted correct and 0 was predicted correct and 9 was predicted correct. But here the 0 was not correctly predicted, but it was predicted as 9 because the accuracy was not completely 100%. No algorithm can give 100% prediction, but they will, while we are training with effective methods, we are going to get nearly most accurate predictions. Here when we are training it with better accuracy, better methods, we are getting nearly 0.99, means 99% of the accuracy is being attained. But here so as we attain 99%, here one prediction was wrong. Uh, After that everything was cut like 70303, and the thing was it predicted 9 with better accuracy, because there will be a confusion between 9 and 1, so that the prediction was completely accurate. So for third party app, GPU or the GUI for touchscreen recognition, we have installed radio. Here we can face a problem called, while we're writing in touchscreen, the strokes or the smoothness of the digit we are writing may not be clear, so that the model can predict the 7 as 1, or 9 as 1, or 9 as 0, and 6 as 0, and different kind of predictions may happen if the model was trained better. But if the smoothness while writing the digit on the touch screen is not clear, it may decrease the prediction will be wrong. We may think that the prediction is wrong as the accuracy was less, but with better accuracy also, when the smoothness is getting recorded, the accuracy, the prediction might be wrong. So this is how we are going to complete a handwritten digit classification project where the machine learning is meeting the human creativity. So this is how we are going to conclude about the handwritten digit classification project. And I had shared my experiences and the problems that I had faced when while doing the recognition and classification of these handwritten digits.
Earlier, my teammate had described about the working of CNN and they have shown even the code for the MNIST. My name is Dinesh Kumar. Today I'm going to show you the code for the EMNIST. So there were two choices to use on. That is, we are having two frameworks to use on. That is PyTorch and TensorFlow. So we have of PyTorch as the framework because we need to use like the it is mostly widely used now, and even the Tesla and ChatGPT are using PyTorch. So we opted PyTorch for that. And Matplotlib and Seaborn is used for the visualization. So we need to visualize that how the data looks and etc. So we need to import pandas and numpy as it is used for the numerical calculations, and we need to read the data. So that's why we are using pandas and numpy in this. And as I described earlier, the Seaborn and Matplotlib used for the visualization. Torch is nothing but the PyTorch. And in the torch.nn, that is neural network, the neural network is consisting in not torch.nn. So we are importing that for that purpose. And and basically we are importing optimizer in order to reduce like the loss, and we need to change the parameters in order to reduce the loss. So that is mainly done with optimizer. And accuracy score is just we need to check how the model is performing, how it is performing on the test and train. And basically the model underscore selection is used to import like train test split. We need to first of all, like if we get the data, we need to split the data into train and test. So we need to train the model like this is the image. If this image is like this, you need to perform the answer as 2. So we need to tell the model like that. And after training the model, we need to test the model, right? Like if the teacher teaches you something, so she needs to check whether you have understood or not. That's what we are doing here. Like we are testing the model how it is performing. And transform is used to transform the images. Like we need to transform every image into 28 pixel, that is height and width. To maintain equal height and width, we are using transforms. So data loader is used when the PyTorch can't support directly the data. So we need to ensure that it is easily fetchable for the PyTorch. So we are converting using the data loader for that. And pd.read underscore CSV is used to read the data which we are having. Here it is emnist digits train.csv. And for our easy purpose, we are making the label as a first column, and other columns we are just renaming as pixel 1, pixel 2, pixel 3 like that. It's just for our easy purpose to understand. And we are visualizing the data here, like how much 0 is consisting in the handwritten digits and 1 is consisting, basically it is labels, like how much 0 labels are consisting. So it is like every are consisting of 23,000. So it is not even biased, or it is balanced data. And here we are visualizing like how images are there. We can see here MNIST is very easy to understand. Even the humans can understand easily. But if you look the EMNIST visualization, the label 5, which is look here, it is like this. Even we can't identify it as 5. And 2 is like this, 4, 4, okay. 5 is like this. So we need to ensure that the model needs to predict this correctly. So we need to make model that much tougher. And here we are normalizing the pixel values. Like it basically it will be having up to 0 to 255. So we are dividing by 255 and making it to 0 comma 1, and we are converting the label data into the value of int64 or float64. It's our own wish to convert into one. And here we are splitting the train test data. So earlier I described about that. And we are splitting as train as 80% and test as 20%. So here we are converting it the torch type, like torch x underscore train should be converted into the torch sensor type, and x underscore test is even converted into the torch sensor type in order to in order to model to understand. And data loader, which is used to convert into the PyTorch specifications. And here we are giving the batch as 64. Like after one batch consists of some images and another batch, like that it will be consisting of the 64 batches. And we are shuffling the data, like in order to, like the model needs to be predicting the accurately, and it should not be biased. So that's why we are shuffling. Sometimes like the label 1111 comes continuous and 2 will be after that continuous. So we are making to ensure that it will be 1567 like that. We are here with the model here. So this is model, and it is importing the nn dot module as we are working on the neural networks. And basically input shape is equal to 1. In it is if you look here, it is an black and white image. For RGB image, it will be 3, which is red, green, blue. It is only having black and white. So we are giving the input shape as 1. And hidden units is our own choice. Like we can give 64, 128. Higher hidden units are more accurate, and it is very easy to do it. So it is converted here. And output shape is equal to 10 because we are going to predict the label 0 to 10, 0 to 9, sorry. So that's why the output shape is equal to 10. And super emnist underscore cn is used to, like we need to have the parent module, so that's why we are using this. So basically the dot sequential, like we are giving the input shape as first of all 1, and output channels as 32, and kernel size. So basically kernel size is like a matrix, and the image is in the matrix, like stride equal to 1, it will change according to one column here. And padding is like if you have 3 cross 3 matrix, it will be changing into the 5 cross 5 matrix if you apply padding. Padding equal to 1 means like if the matrix is 3 cross 3, it will add in front one column, and uh, before ending it will add one column. So that is the use for this. And convolution layer is used to fetch the image which is used to working on CNN. And relu is basically an activation function which is used to uh, include the non-linearity. And again we are giving the convolution layer. So we are here given output channels are 32, so we need to give input channels according to this. So if 32 is given, we need to give input channels as 32 on here only. And output channels we have given 32, the same specification, kernel, stride and padding. And we are applying activation layer again. And max pole 2D is used when, like if you are having the matrix 228, 128, 128 and 64, so it will take the 228 value as we are applying the max pole 2D. Like it will fetch the, like the important thing in the image. And we are applying again the convolution block. So here we are given the output channel as 32, we need to apply here input channel as 32 here only. and output channels is we are applying a 64 and kernel stride padding, again the same specification. We are applying the activation layer in order to increase the non-linearity so that the model will perform good. So that's why we are applying the activation layer. And again the same things. Classify block is used to convert the output into our desired output, such as we need to have the digits from 0 to 9 here. So we need to convert according to that. Flattening is used to convert the multi-dimensional array into the single dimensional array. And NN.linear is used to define a fully connected layer in a network. And input features we need to convert into the output features. So 64 into 77, such as it will be coming around 1028 or something. So it will be converted into 256 first of all, and we are applying the activation layer here, which is relu. And dropout is used to find out like 50 percentage of the, it will reduce it will reduce into the 50 percentage consisting of only important thing. And the 256 we are again converting into the 128, and we are applying again the activation layer, and we are reducing the like we need to have only important features as a 50 percentage. We are doing it again, and here the output feature is 128, and 128 at last it is getting converted into the our output shape, which is 10. And forward is a method which is used to give the, like, in order to perform the layers, in order to perform inside the layers. So we are first of all giving the data to the convolution layer, and after getting the result, that that thing is again passed here. The convolution x here is passed here, and if it performs something in convolution 2D, and it will take x here and it will put here, and at last it is returning x. And I'll describe this. And we are going to train our model. And nn dot cross entropy loss, which is the logs function which is used for the which is used to predict the multi-class thing. So we are using cross entropy loss for that. And optimizer, there are Adam, SGD, RMS prom. Adam is the best thing which we can perform here. And we are like epochs is nothing but how much time we are going to train our model. And we are passing the images and labels in the train loader, and you can see here the height and width of the image is 2828, and the input shape 1, which is 1 because it is an black and white image, and -1, which is the batch size we are not like familiar about, so we are giving the -1. And we are making the gradient as 0 because we don't need to have the previous things. So we are making as the gradients as 0, and we are performing the loss function here. And loss dot backward and optimizer dot step is like we need to change, it will change the parameters, and it will reduce the loss here. So it will make the model more accurate here. It will goes on changing the parameter, and it will stuck into that which is most suitable here. And toss dot max, which is which thing is the most predicted one, which is more accurate here. So that's what we are doing here. And the model.deval is used to test the data, which is the same things which we performed on the test training data also. And here you could see that we have used Adam here. And the train, first of all, the train loss was 0.1347, and it got reduced in 0.0169. As more as the epochs, the more as the model understands, but it takes more time here. And the first of all test accuracy was 0.9904, and it got increased to 0.9948. And at last we have saved the model. So in this we can understand how the, like how we have performed the CNN for the EMNIST model here. Thank you.